Hi y'all, hello and welcome to your Unit 3 quiz review, or as I like to call it, Miss Avra is still not as good at these videos as Miss Keys is, even as much as she tries. I'm going to do the example problem on the left, and then you are going to pause and practice and do the practice problems on the right. Answer keys will be posted on the board so you can check your work as you go. So our first tool in our triangle trig toolkit is interior angles of a triangle equal 180 degrees. What this means is I know that this angle, and this angle should add up to 180 degrees. So if I am given two angles of a triangle, I can find a missing angle using this tool. Okay, so here I know that the entire triangle would be 180 degrees, and that I can subtract out this 40 degrees here, subtract out this. I know that this square here means 90 degrees, so minus 90 degrees, and that whatever's left over will be my value of x, or this angle here. So if I do 180, or the total minus angle 1 minus angle 2. Okay, so 180 minus 40 minus 90 equals 50. That means my missing angle here, x is equal to 50 degrees. Okay, so quick example problem on that. Now I want you to pause and practice and complete these two practice problems. Okay, I'm assuming you have paused and practiced, and we are ready to move on to the next skill in our triangle trig toolkit. The next skill here is our sine rule. Sine rule helps us find missing sides or missing angles, so we can find sides or angles of a triangle when we are given an angle and its opposite side. So we must be given an angle and its opposite side in order to use sine rule. Okay, so if I'm looking at this triangle here, the first thing that I see is that there are 2 of 3 angles in this triangle, which means the first thing that I want to do is find this missing angle here. Okay, so I know that the total triangle is 180 degrees, and I can subtract out the other 2 angles. So 180 minus this angle minus this angle, 180 minus 95 minus 34 gives me 51. So I know this angle measure here is 51 degrees. Okay, but that still hasn't answered my question of find the measure of AC. So measure of AC is a side length. We're looking for this side right here. Okay, so we're looking for the measure of AC, which is this side right here. In order to use sine rule, I need an angle and its opposite side. So when I set up these fractions, so we're going to use sine rule to solve here. When I set up my fractions for sine rule, I always set up the first fraction as what I'm given, or the angle and opposite side I'm given, and then the angle and opposite side I'm trying to find. So here I am given an angle and its opposite side. I can't use 95 here because I am not given its opposite side, but I can use, oh, I made this confusing. This is the one we're trying to find, so we'll do it in green so it matches. Okay, so the one I'm given 51, or in this case I found 51, and its opposite side is 32. So my first fraction is going to be sine of 51 over 32 is equal to the fraction that I'm trying to find. So this is the side that I'm trying to find. I'm going to call it x. We're going to put x on the bottom of this fraction because the side lengths should line up as denominators. And I'm trying to, this is the side I'm trying to find. This is its opposite angle, so sine of 34 on the top of my fractions. Now when I have a single fraction equal to a single fraction, it means that I can cross multiply. So I'm going to multiply the top of the first fraction by the bottom of the second fraction, bottom of the first fraction by the top of the second fraction. That's going to give me x sine of 51 is equal to 32 sine of 34. Okay, my goal is to get x totally by itself. X isn't totally by itself yet, but it is right in front of sine 51, which means multiplication is happening. So I'm going to divide by sine of 51 on both sides. And when I plug that into my calculator, let me first make sure this one is on degree mode. It is. I'm going to set up my fraction bar, 32 sine, the trig button's on the top left here, of 34 over sine of 51. Pop that into my calculator and I get 23.0255. I'm going to round that to 23.03. So x is equal to 23.03 kilometers. Don't forget your unit here in kilometers. So x, this side, is equal to 23.03. Okay? So sine rule, biggest thing to remember here is when you're given an angle and its opposite side, it can help you find the sides or angles of the triangle. From here, you are going to pause and practice. Complete this practice problem on the right before you move on. Okay, we are assuming you have paused and practiced, and moving on to our next tool in our trig toolkit, which is our cosine rule. Now, cosine rule is a little bit tricky because it is a formula. Cosine rule works really well if to find sides or angles of a triangle when you're given 3 sides. Works for 3 sides of a triangle, so you can find it when given 3 sides. You can also find it when you're given an angle, or when you're given an angle and the 2 included sides. The angle and the 2 included sides, because you don't necessarily have an angle and its opposite side. Okay, so usually we use cosine rule when we can't find a way to use sine rule. I'm going to give you this example here, even though you theoretically could use sine rule, but we're going to use cosine rule here. You've got 2 versions of your cosine rule formula. The first one here is to find a missing side. The second one here is to find a missing angle. So the 2 formulas help us find 2 different things. They are essentially just rewritten versions of the same formula. Okay? So this one says find the measure of BAC. So BAC is this angle here. This is the angle that I'm looking for. Now the tricky thing about the cosine formula is the letters of the triangle don't always match up to the letters in the formula. So what I always do is I relabel my triangle so that the angle I'm looking for is always angle C. It's the one you're looking for. So I relabel my triangle. I just make this angle C, and I'm going to make that angle A. I'm going to switch it so it fits my formula better. Okay? So if I'm looking at this, I need to pick which formula I'm going to use first. It says find the measure of angle BAC. So I'm going to use the formula that helps me find a missing angle. So that's cosine C is equal to A squared plus B squared minus C squared, all of that over 2AB. Okay? So if I'm looking at this, the most important thing here is plugging in the correct values for C. C is always the angle you're looking for and its opposite side. So cosine C here, if I'm labeling my variables, cosine of C is going to be what I'm looking for. Side C is going to be equal to 29. And then for A and B, it doesn't matter which side you pick for A and which side you pick for B, because they're being multiplied. These 2 are just the other sides that are not the sides opposite of the angle you're looking for. So I'm going to say A is 25 and B is 28, just my other two sides. From there, I'm just going to plug it into my formula. So I've got cosine of C is equal to A squared. I said A is 25, so 25 squared plus B squared, which is 28 squared, minus C squared, which is 29 squared. It's the side opposite of the angle I'm looking for. All of that over 2 times my side A, which I said was 25, times my side B, which I said was 28. Okay? From there, you can plug all of that into your calculator. So I'm going to do 25 squared plus 28 squared minus 29 squared. All of that over 2 times 25 times 28. And I get this crazy fraction here, 71 over 75. So I've now got cosine C is equal to 71 over 175, sorry. Now here I need to get C totally by itself, which means I need to cancel out this cosine here. To cancel out cosine, essentially what we have to do is inverse cosine, or inverse operations. So if I do cosine to the -1, it will cancel out this cosine here. But if I do cosine to the -1 of this side of the equation, I have to do the same thing to the other side of the equation. So these cancel, and I'm left with C is equal to cosine to the -1 of 71 over 175. If I plug that into my calculator, I get here, if you go to your trig button, cosine -1 of 71 divided by 175, I got 66.01. So C is equal to 66.01 degrees. Okay, cosine rule, it's most important for cosine rule to make sure that you are pairing up the angle you're looking for with its opposite side, always plugged in for C. Okay. From here, you are going to pause and practice, try cosine rule on this problem here, and you only got 2 more tools in your triangle trig toolkit. Okay, I'm assuming we've paused and are ready to move on. Next, we're going to look at area of a triangle. Area of a triangle is 1/2 AB times the sine of C. Biggest thing here, sine of C. C has to be your included angle. Okay, the included angle is the one that is included or the one that is created by sides A and B, by the 2 sides that you're plugging into the area formula here. So if I'm looking at this, I'm going to say 7 is equal to A, 6 is equal to B. 100 is my included angle because it is the angle created by the 2 sides of the triangle that I'm plugging into my formula. So I've got A is equal to 1/2 AB sine C, just like the formula has up here. I've labeled my variables so I can plug them straight into my formula. A is equal to 1/2 times A, which is 7, B, which is 6, and then sine of my included angle, 100. From there, I can plug that straight into my calculator. 1/2 times 7 times 6 times sine of 100. That gives me 20.68. So area is equal to 20.68 centimeters squared. Area is always in centimeter or in units squared. Okay, that one's a little more straightforward with the formula than cosine rule. If you will pause and practice completing this example problem on the right. Now we are done pausing and practicing. Moving to our very last page. First thing that we're going to look at is tool 5, which is radians, are converting from radians to degrees. Remember, if we start in radians, we multiply by 180 over pi. If we start in degrees, we multiply by pi over 180. So here I've got 150 degrees. So I'm going to do 150 over 1 to set this up as a fraction. Times, I'm starting in degrees, which means I want degrees on the bottom of my fraction, radians on the top, When we multiply fractions, we multiply straight across. So this becomes 150 pi over 180. I bring the pi over from my denominator, or excuse me, from my numerator. Pi stays in the top. And I'm going to reduce this fraction. The fraction bar means division, so I can do 150 divided by 180 in my calculator, and I get 5 over 6. So my final simplified radian is 5 pi over 6 radians. Very, very similar process when we start with radians, just one small change. I've got 2 pi over 9 radians. I don't have to set this up as a fraction because it already is a fraction. I'm just going to multiply it by, this time I have radians in the top, so I'm going to put radians in the bottom of my fraction, so pi, so these will cancel, over 180. Again, when I multiply fractions, I multiply straight across, leaving pi where it is. 2 times 180 is going to give me 360. 9 times pi is going to give me 9 pi. Notice I have a pi in the top and a pi in the bottom. Those will cancel. And then I can just plug in 360 divided by 9, which gives me 40. So I've converted that to 40 degrees. Okay. You are now going to pause and practice. Move on to these 2 practice problems, converting degrees to radians and radians to degrees. Last and final tool in your triangle trig toolkit. Wow, I've been talking for so long and I am so hungry, but that's okay. We've got one more thing to do. Okay, arc length and sector area. Arc length is the distance of part of the circumference. So here when it says the length of arc AB, it means this length right here. And then sector area, or this formula over here, is the space inside, or the area inside just a sector of the circle. Okay, so on this one, we're going to find the arc length first, and then we're going to find the sector area. Now, biggest thing with these formulas is theta, or this degree measure, must be in radians. Okay, we must have our unit in radians first. So if I'm looking at this, I see 120 degrees. I'm going to have to convert that to radians first. So I have 120 over 1 times pi over 180, which will leave me 120 pi over 180. Let's divide that down. 120 divided by 180 gives me 2 over 3. So in radians, I've got 2 pi over 3. Now that that is in radians, that's something that I can plug into my formula. So here, I know that for both of these formulas, theta is going to equal 2 pi over 3. And r is our radius, so r is equal to 6. First formula we're going to use is arc length. L is equal to theta times r. From here, you can just plug in your values into your formula. Length is equal to 2 pi over 3 times 6. I'm going to pop that straight into my calculator. 2 pi over 3. That gives me, I forgot to multiply it by 6. Times 6 gives me 12.566. So length is equal to 12.57 centimeters in this case is our arc length. So our length here is 12.5 centimeters. Sector area is very similar. We're using the same values. We're just plugging them into a different formula. Got area is equal to 1/2 theta r squared. So area is equal to 1/2 theta 2 pi over 3 times r, my radius is 6, squared. Again, pop that straight into my calculator. 1/2 times 2 pi over 3 times 6 squared. Oops, typed that in wrong. Times 6 squared gives me 37.6991. So area is equal to 37.7 centimeters squared. Again, don't forget your units there. Boy, oh boy, we made it. Pause and practice for the last and final time on this problem here. And then whoop-de-doo, you've made it to the end of the review packet. I am so proud of you. Come give me a high five or something. That's it. Have fun and practice. Like and subscribe. Let's get me up to 25 subscribers. Big day.